Welcome to our presentation on blockchain voting, presented by Team 8. Today we will be taking you over a brief introduction to our team, our project idea, the algorithms used in the project, how the workload was distributed, and a list of our references. Our team consisted of 3 members. Johan Royce is our lead researcher, Srijan Chaudhry is our lead programmer, and myself, Mohammed Musab, am a team member. Our project idea started off by us reflecting on the 2020 US presidential elections, where President Trump lost, and after losing, Trump expressed doubts regarding the current voting system, calling into question its validity, causing national unrest, ultimately leading to a standoff held by Trump supporters on Capitol Hill. Our team realized that had the voting been preserved in the form of a blockchain, none would doubt the results of an election. So let's talk about blockchain voting. Blockchain voting is an innovative solution to modernize elections by leveraging decentralized technology. It ensures transparency, security, and tamper-proof records, addressing challenges like fraud and voter intimidation. By utilizing cryptographic algorithms, blockchain preserves voter anonymity while making election results verifiable by the entire public. Its decentralized nature eliminates reliance on intermediaries, reducing risks of manipulation. Additionally, blockchain voting enhances accessibility, allowing individuals to cast ballots conveniently from their own devices at home. This approach fosters trust in democratic systems, empowers citizens, and promotes higher voter turnout by making elections more secure and inclusive.
Hello everyone, my name is Srijan, and today I want to explain the algorithms and logics used behind our voting project. Yes. So we start off creating our Genesis block, and this is probably the best place to start because it sets the foundation for the rest of the blocks, right? So the Genesis block contains a lot of things for Genesis information. Sorry, I was just pulling up what exactly we needed. So we needed index, the votes, the nonce that is got from which is sent by the proof of work, the previous hash that it's not there for Genesis block because before Genesis there's nothing, right? So it's followed by 64 zeros, right? The timestamp of the Genesis block, and yeah, the proof of work essentially sends back the current hash using SHA-256, and that is through another function for hash, but it's not really important in the large scale. So that's essentially how the Genesis block works, and once that is created, it's added to the blockchain. Now, since we know how the block is, or what the block is, let's talk about the input field. Because when you want to vote, you have to put in your details usually. Especially for government, you have to put a lot of detail like your age and address and etc. etc. But for this case, it's just a normal voting, whatever you want to vote for, right? So, the user input, you have to put your name, the voter's ID, which is your ID, the address of the voter, and which candidate you would like to vote for. But when you click submit, it also sends a 5th hidden one, which is called timestamp, and this timestamp is always carried with this input, right? So that's just how the input field is collected. But I want to talk about another field, current votes, right? So current votes are all the votes that are there before the block is mined, right? And we did this because we want to add as many votes into our block before it actually mines, I guess. I wouldn't really call it mining, but we'll get to that soon. It's more like validating the blocks, right? So the current votes just contain votes before mining, and after you mine the votes, well, not mine the votes, mine the block, it sets back to 0 or empty, right? So in our code, we can set the max votes, and if that max vote is reached, we go to the next step, where is the program comes in. So the person running, the miner, right, he will propose a block with all these current votes, right? The current vote is sent to the miner, and he proposes a block using the propose block function, which is exactly the same as this, right? Which is a create block function. So what it takes index. Well, it doesn't take index, it sets the index. It has the votes, the nonce, that's from proof of work, the timestamp of the proposed block. And I want to clarify that this timestamp is the only time proposed block will have one. When we talk about them, it will be more clear. And the current hash of the proposed block. Now the thing is, we don't want that proposed block to be added directly to the blockchain, because if there's malicious inputs from the miner, that could disrupt the blockchain, right? So to tackle that, we brought in 3 validators. Actually, does not have to be 3. It can be as many as you want, but in our program it's 3. And what they essentially do, they run the same exact well, they're supposed to run the same exact hashing functions using votes, previous hash, timestamps, right? And the timestamp is from the proposed block. So that's the only thing that's used from proposed block. Everything else is grabbed from the user input, right? So it's, in theory, it should be an identical copy of proposed blocks, right? So what they do is they make the hash, they check if this hash validate, let's say call this guy validation 1, right? His hash is the same as the proposed block's hash. He says, okay, this guy is valid. These two do that as well. And if one of them even get it wrong and the other one gets, like, well, not wrong, but he doesn't validate and the other one does, it would count as a valid block, because in our logic it works as a majority. So 2 out of 3 is like, well, 66%, and that's majority. And when that's the case, it is added to the blockchain after the validation. So what's great about this is you can always have more validators, right? Especially with 3 right now, it's very you could easily do a 51% attack where you can have like 2 false malicious validators, right? But the more you have, the better it gets. And that's what this entire system is built on. You can essentially scale this very easily. And the blockchain, the difficulty of it of calculations is like practically it's incredibly easy for computers, right? Because especially in our project, we don't really care if our mining takes long or it's computationally extensive. What we care about is we want to make sure it's the integrity of the data, right? That's why after the miner is picked, 3 other validators validate the block, and if that's valid, it is added to the blockchain. And that's essentially the brief overview of our system, and I will pass it on to the next person.
Hello everyone, my name is Johan Royce, and here I'm going to show you a quick demo of our blockchain voting system. So right here we're at our home page over here, and here we have a little introduction to blockchain, why we chose blockchain for voting, and as well as some of the features included. Here we can see that our program is able to secure and immune storage of votes. We're able to have real-time voting tracking and transparent results. We also benefit from a decentralized architecture with no single point of failure, as well as designed for scalability for future integration. And with that, we also have two links, one to view the blockchain itself and another to cast your vote. So let's go right there. So in the blockchain, we could see the list of every block that's been added to the blockchain. Right here, number 1, we have the Genesis block, which is the very start. As you can see, there's no votes since as the Genesis block, no votes have been added. As you can see all the way down, you can see all the votes have been recent. Most recent one is block 9, so that's the most recent block that's been added. And also you also notice that each block contains two votes, so for every 2 voters who enter, we validate a block. So now let's go to the voters page. In the voters page, you'll see that the person can enter their ID, their name, their address, and in this case, the person they vote for. In this case, instead of presidents, we have types of blockchain. We have Ethereum and Bitcoin, one of the 2 cryptocurrencies. So let's start with the ID. Let's say let's start with let's put name as ID as 10/30/1950. Let's go with that. And then we have our name. Let's say Charlie Brown. And then our address. Let's say Sparksville. And then let's say we choose, I don't know, let's vote for Bitcoin. Now we press submit. And it says right here, notification says vote added successfully for Charlie Brown. So that's how we know it's been added. And let's go back to the blockchain. Let's see if anything happened. And okay, we saw that, yeah, he's been added. So blockchain has been added. So that's nice. Now we have 10. Now let's go back to voters. I want to show you something. Now you might ask, well, what if somebody tries the same one? Would that change anything? So let's try 10/30/1950. Let's say, so you know, you don't want to have multiple people, the same person voting at the same time. So let's try Charlie Brown. Let's try maybe a different address. Snoopy Doghouse. And let's try let's try Ethereum again. Say vote. It says right here now, it says voters already voted in the blockchain. So what this benefits is that now a person who's already voted can't be voted. And let's say maybe it's the name. Is it the name? Let's see, is Snoopy. Submit vote. It still doesn't work. See, it's the number, the ID number that defines who a person is. So for every ID, which is unique, only 1 vote is allowed. So let's change the date to November. So let's try 11/1, and let's try Snoopy, and successfully added. So it's been successfully added. And as you can see, no new blockchain has been added since it's still waiting for 1 more vote before it creates a new blockchain, block in the blockchain. And over here, we have the results page. So now a person, anyone who has access, can see the live feed of every of the amount of what each person voted. So as you can see, overall 5 people voted for Ethereum, 30 people voted for Bitcoin. So the benefit of this is now there's no need to count for any votes. Now all of it can be done automatically in this program. So it helps save a lot of time as well. Alright, now we move on to the slide that explains who did what. So, for the research paper, Johan Royce, myself, did questions 1 to 4 to 7. Musab, he did questions 3, 8, and 9. For the implementation, basically the program of our application, it was programmed by Srijan and Musab, and I, Johan, was the website designer who did all the layout and all that. And as for the presentation, all of us, me, Musab, and Srijan, all took part in the making of this presentation that you see before us. And that's all, folks. Here's citations of all the people who helped us along the journey of bringing you this presentation. Thank you, and hope you consider having e-voting with blockchains in the future. So thank you for the presentation, and see you around.